So let's do this one question here. By using image theory, we want to find the electric field at this location in the region z greater than 0. That means anywhere in this region, z greater than 0. So this is the z equal to 0 plane. That is in fact the xy plane. Z is 0. How would I be able to find the electric field? Due to this, you know that this height is going to be d. Z is going to be d because the z coordinate is d. So you can apply image theory then immediately to tell that then my real scenario is if I want to find the electric field in this region, at any point on that region, which is x, y, and z, source is not just one charge, but there is also an image charge, which is minus d away. So if this is plus q, then this guy is minus q. So all that now remains is there are 2 point charges now. The electric, so my location where I find the electric field is x hat plus y hat plus z hat. Why so? Because this has the x coordinate, y coordinate, and z coordinate. X, y, and z. This is the position vector of this point. So once you have an electric field here at that location, it's not only going to be due to this plus charge, but it's also going to be due to the negative charge. So you're going to have 2 terms in it, which will have still the 1/4 pi epsilon naught. Then I can have this to be my, this is my observation. I can have my R1, not this capital R1, okay, the small R1, which is going to be this guy, which is going to be simply dz hat, because there's no x and no y. And I have my R2, or I can call this R source and R image. It's easier that way. R source is the location of the source, and R image, maybe I write R image here, ing, is going to be minus dz hat. My R source is plus dz hat, my R image is negative z hat because it's in the negative d. So what can I have here then? The plus q R minus R source, this vector divided by the magnitude R minus R source, the whole cube, plus minus q of R minus R image over R minus R image, the whole cube. So you can go ahead and substitute your R image in here. You can go ahead and substitute your R in here, and you can reduce that. So if you were to really go ahead and do that, since the Q and the Q are there, you can take the Q common outside. It will become Q over 4 pi epsilon naught. Then it becomes x hat plus y hat plus z minus d z hat over the magnitude of this square, which is x square plus y square plus z minus d the whole square to the power 3/2 minus x hat plus y hat plus z plus dz hat. This minus will become plus, this plus d will become minus, yeah. So this many volts per meter, that's the electric field at this point. So you're in a way able to find it as sum of 2 point sources. So if you have, this is x-axis, this is the y-axis, this is the z-axis, then the z equal to 0 means any point on this surface. So the xy plane is also called as z equal to 0 plane, because you know that a surface, one of the coordinates is a constant, and turns out that for this surface, the constant coordinate is z, and the coordinate value is 0. If you have, let's say, a plus q charge here, let's say plus q1, and let's say minus q2 here, this is at a, let's say, height of h1, and this is say at a height of h2. Then you're going to have, this is the metal surface. So there are two source charges. So you'll have two image charges. So in this case, you're having two sources, right? You'll have two images. So you're going to have one image which is minus q1 here. But since the source is minus q2 here, this is going to be plus q2 here. But then this is going to be at negative h2, yeah? This is going to be negative h1. So if I were to find an electric field at this point, it is going to be due to this guy, due to this guy, due to this guy, as well as due to this guy. There are going to be four terms now. Two source charges and two image charges.